A jar of peanut butter looks calm on a shelf, but inside the factory, the hardest part is control. So how does a factory take dry peanuts and turn them into peanut butter that looks the same, spreads the same, and tastes the same every time? It starts long before anything is ground. Shelled peanuts arrive at the plant in heavy bags, totes, or bulk containers, removed from their outer shells but still not ready. They pour into receiving bins like pale tan stones, dry, uneven, and mixed with tiny pieces of dust, stems, skins, and broken nuts. Conveyors carry them forward in a wide, moving layer that workers nearby can inspect the layer closely. Workers take samples from each lot before the peanuts join the main line. They check moisture, color, smell, and damage. From receiving, the peanuts travel into cleaning equipment. They shake across vibrating screens that separate oversized pieces from small fragments. Air lifts away light dust and loose skins. Magnets guard the line from metal. Dense stones or heavier foreign pieces are pushed away from the peanut stem. Only clean nuts should reach the heat. But how does the factory catch bad peanuts before they disappear into the batch? The next answer is sorting. The peanuts spread into a thin moving layer across inspection belts and optical sorters. Cameras scan for dark spots, moldy pieces, shriveled nuts, and anything that does not match the right color. Bursts of air knock rejected pieces into chutes. What remains is a cleaner, more even stream, ready for the step that creates most of the flavor. The peanuts enter the roaster. Some factories use batch roasters, where measured loads tumble inside heated drums. Others use continuous roasters, where peanuts move through a long heated chamber on belts or inside rotating systems. Hot air surrounds them as moisture drops and the pale nuts slowly take on a toasted color. The smell changes too. Raw, grassy notes fade, and the familiar roasted peanut aroma begins to build. This step has to be controlled closely. Too little heat leaves that flavor flat and the texture harder to grind. Too much heat makes the nuts dark, bitter, and dry. Time, temperature, airflow, and the peanut size all matter. But the viewer can see the result in the color. The factory is trying to land every batch in the same narrow zone, not pale, not burnt, but roasted enough to taste rich. As soon as the peanuts leave the roaster, they're still cooking from their own heat. Why does the factory cool them so fast? Because if they stay hot for too long, the roast keeps moving past the target. The peanuts spread across the cooling beds, where fans pull air through the layer. Heat escapes quickly. The roasted nuts stop darkening, and the line can move on without losing the flavor the roaster just built. Now the peanuts need to lose their skins. The thin red skins are loosened by heat and rubbing, then removed by blanching machines. Peanuts pass between rollers on abrasive surfaces that crack and rub the skins away. Air suction lifts the papery skins from the line, leaving lighter, cleaner peanut halves behind. Those skins may look harmless, but too many of them can add dark flecks and a slightly bitter taste to the finished spread. After blanching, the peanuts are sorted again. This is a final cleanup before grinding. Burnt pieces, stubborn skin fragments, and discolored nuts are easier to spot now that the surface is exposed. Some lines use workers at inspection belts, others rely heavily on optical sorting. The product is still recognizably peanuts, but it has been cleaned, roasted, cooled, skinned, split, and checked several times. By now, the factory has prepared the peanuts for the most important change. They are dry, roasted pieces entering the grinder. A moment later, they are no longer loose nuts. They become a thick paste. How does a dry peanut turn into something that flows? The first grinder crushes the roasted peanuts between metal plates, stones, or high-speed cutting surfaces. The pieces break smaller and smaller. At the same time, natural peanut oil begins to release from inside the cells. That oil coats the crushed particles, and the mixture changes from chopped nuts into a coarse, warm paste. This first paste is not yet the peanut butter most people expect. It is thick, gritty, and uneven. It moves slowly through stainless steel pipes into another mill where the second grind makes the texture finer. The gap between grinding surfaces is tighter. The particles become smaller. The paste grows smoother and glossier as more oil spreads through it. This is the moment where the product starts to look familiar. The grinding area is one of the most active parts of the plant. Roasted peanuts drop into hoppers from above. Motors drive heavy mills. Warm peanut paste pushes through pipes under pressure. A steady stream flows into mixing tanks, where the formula is finished. For creamy peanut butter, the factory wants a uniform paste with no large pieces. For crunchy peanut butter, part of the smooth base will meet carefully sized peanut granules later. Before that happens, the mixture adds the recipe ingredients. Salt may be measured into the tank. Sugar or sweetener may be added for balance. In many conventional peanut butters, a small amount of stabilizing ingredient is blended in to help control separation. The mixture folds over itself slowly under rotating paddles, thick but still warm enough to move. What keeps the oil from rising to the top? Natural peanut oil wants to separate over time, especially if the paste is left alone. Stabilizers and proper mixing help hold the peanut solids and oil together so the jar stays smooth during storage. The factory does not need to change the peanut flavor dramatically. It needs to keep the texture dependable from the filling line to the kitchen table. For crunchy peanut butter, another stream enters the process. Roasted peanut pieces are chopped into a controlled size, cleaned to dust, and metered into the smooth base. The mixture turns slowly so the pieces spread evenly without being smashed into powder. Too many pieces in one area would make a jar feel uneven. Too few would make it seem like the crunch disappeared. The goal is steady texture from the first spoonful to the last. Once the mix is ready, temperature becomes important again. Peanut butter that is too cool may not flow cleanly into jars. Peanut butter that is too hot may affect texture after filling. The product may pass through holding tanks, pumps, and sometimes vacuum systems that remove trapped air. Air bubbles can make filling less accurate and leave gaps under the lid. The line wants a smooth, dense stream. Now the peanut butter reaches the filling machines. Empty jars move in rows or conveyors, open side up, clean and ready. Filling heads lower in position or hover just above each container. Pumps push measured amounts of warm peanut butter through nozzles. Each jar fills from the bottom upward or from a controlled stream, helping reduce trapped air and mess on the rim. The once dry peanuts are now moving as a thick ribbon into hundreds of containers. The filled jars continue straight into capping. Lids are fed from a bowl or chute, placed onto the jars, and tightened by rotating heads. Some containers pass under induction sealing equipment where a liner bonds to the mouth of the jar. This inner seal helps protect the product, prevent leaks, and show that the jar has not been opened. Any peanut butter on the rim can interfere with sealing, so clean filling matters. Before the jars become finished goods, the factory checks them at several points. Some checks happen in the lab, where samples are tested for texture, flavor, color, moisture, and safety. Others happen directly on the line. Check weighers confirm the fill amount. Metal detectors scan sealed jars or product streams. Cameras check lid placement, label position, and printed codes. Workers may open sample jars to look for smoothness, oil separation, air pockets, or uneven peanut pieces. The label turns the sealed jar into a store-ready product. Labeling machines wrap each container with brand panels, nutrition details, barcodes, and product names. Inkjet printers add lots of numbers and dates, so every jar can be traced back through the plant if needed. Creamy, crunchy, salted, unsalted, and other versions move on separate runs or changeovers, with the line cleaned and adjusted between products. Packaging now becomes fast and mechanical. Jars gather into groups, slide into cardboard cases, and pass through case sealers. The cartons close, tape or glue locks the flaps, and printed marks identify the product inside. Cases stack onto pallets in neat layers. A stretch wrapper spins around the load, pulling plastic film tight so the cases stay together during warehouse handling and truck movement. By the time the pallets leave the packaging area, the peanuts have changed form completely. They arrived as dry, separate nuts with skins, dust, color differences, and hidden defects. They leave as sealed jars of smooth or crunchy peanut butter, coated, boxed, and ready for distribution. Forklifts carry the pallets into storage, where they wait for orders from stores, restaurants, schools, and food service warehouses. From there, the journey becomes familiar. A truck carries the case away from the factory. A stocker opens the carton. A jar lands on a shelf, looking simple and still. But inside that jar is the result of sorting cameras, hot roasters, cooling beds, blanching rollers, heavy grinders, slow mixers, filling nozzles, sealers, and checks at every stage. What began as a stream of dry peanuts has been cleaned, roasted, crushed, blended, sealed, and sent out as a spread that can hold its shape on a knife, even though it started as thousands of individual nuts.